Alright, here we go. So get it started up in here. Notes number 3. Welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video. Today we're going to be looking at something new and something a little bit fresh, maybe, to some of you guys. It's going to be the sums and differences of cubes. But before we start that, we're going to do 2 problems just to review and make sure that we know how to solve by factoring. So write this example down. It's going to be 15x cubed plus 6x equals 21x squared. So we're solving by factoring. Pay attention to the directions. You want to know what the directions say, okay? So if I'm trying to solve this by factoring, what is the very first thing that I should be doing here?
Move the 21.
Move the 21x squared. Why do I need to move the 21x squared? Got to set it equal to 0. That's right. So we end up with 15x cubed minus 21x squared plus 6x equals 0. All right, what would the next step be? The GCF, right? What is the GCF on this equation? Right, but what is it? Is it just 3x? That's right. So half you said x, half you said, so Trey said 3. It's 3x. So 3x is the GCF. So if I factor out 3x, so what am I left with? Right? Wait, what's in the middle? Minus 7x. And then plus 2, that's right. Equals 0. And now we're ready to do the Xbox method. So what is my A value? Here. 5. What's the B value? Negative 7. And what is the C value? 2. So let's draw the Xbox over here. Boom, boom. What's going to go on the top? Which is 10. And what's going to go on the bottom? Negative 7, which was our B value. Okay, so let's find the 2 side values. What numbers multiply to give you 10 but add up to give you negative 7? Negative 5 and negative 2. Very good. What comes after that? 5x on top, and why is it 5x? Because it's a times x, right? All right, so we got our fractions. What do we always do with fractions? Reduce them. So which fraction can you reduce? The left one, the 5x over negative 5, which reduces to what? X over negative 1. Very good. So now tell me, what is my fully factored form from beginning to end? Before that. Before that. Before that. No, not the f of x. We don't need that because we have it equal to 0. But what's before your x minus 1? Look at what you wrote before. 3x. That's right. Don't forget about 3x. That's a factor. Then what else? There you go. Then x minus 1, and then there you go. So don't forget about the part that you factored out at the very beginning, because that is a factor. That's one of your answers in this one. So we have our fully factored form. We're trying to solve by factoring. So how do we solve once we get to this part? Distributing would only take you back to the original, so that's not solving it. How do you solve from here? You set them all equal to 0. That's right. So you have 3 equations here set equal to 0. What are those 3 equations? Right? What else? And? Okay, so for the 3x equals 0, how do I find x? Divide by 3, so x equals? That's right. That's one of my answers. 1 out of 3. Next, I got x minus 1 equals 0. What do? Add 1, so x equals? So that's 2 out of 3 of my answers. And the last one over here, 5x minus 2, what do? Add 2, and then? Divide by 5. So my answer here is x equals? 2 over 5. Good, so there are my 3 answers, and that is solving by factoring. We're going to do one more example, because this next example is one that a lot of people made mistakes on because they kind of make it a little more complicated than it needs to be. So this next example is going to be w squared equals 36w. All right. Feast your eyes on this one. What do you think you would do first on this problem? Subtract 36w, which gives you w squared minus 36w equals 0. What would be next? What's my next step? Take out the W. We're going to factor out the GCF. If I factor out W, what am I left with?
W minus 36.
Okay, so there we go. We're at W times W minus 36 equals 0. And now what?
We equal both of them to 0.
That's right. So some people make the mistake of trying to do the X box here, but that would just leave you very confused because there is no X squared term, or W squared in this case. So right here, it's already factored out. You just got it in the factored form. So you can go ahead and set each expression equal to 0 and get your answers right away. So what are my two equations here? Right, and? Right, W minus 36 equals 0. So W equals 0 and W minus 36 equals 0. W equals 0 is one of my answers, or what's my other answer going to be? 36. And there you go. So don't overcomplicate things. Once you get there, if you see that you can set it equal to 0, do that. All right, so here we go. On to the new content. New type of factoring. Sum and differences of cubes. Yesterday, I showed you the shortcut special situation of difference of squares. That's kind of optional because technically you still could get the answer with the X box. But this time, you're going to have to know this. You're going to have to remember these formulas. So here we go. Sum of cubes and difference of cubes. So let's see what a sum of cubes is. A sum of cubes is when you're in this situation. A cubed plus B cubed. That is a sum of cubes. So what do you think a difference of cubes is then? That is right, A cubed minus B cubed. So we're going to see, how do you factor these types of equations out? There's a formula. And you got to remember this. There's going to be a small set of parentheses and a big set of parentheses. All right, now the terms in each set of parentheses, no matter which one you're doing, sum or difference, it's going to be the same terms. Okay, so as long as you can remember this, A and then B, then it's A squared, AB, and B squared. I'm going to show you how you get the only difference here. Notice how all the terms are the same, right? The only difference is the signs. All right, so I'm going to show you how a good way to remember which sign goes with which formula. So the last sign in between the A, B, and B squared, this sign is always going to be a plus sign. Always a plus sign. Okay? Then the very first sign inside the small set of parentheses is going to be the same as your original. So right here with the sum of cubes, you see it's A cubed plus B cubed, right? So what is the first sign inside the small parentheses going to be? Plus, that's right. What would it be for the difference of cubes? Minus, yes, because it's the same as the original. Then the second sign, the only one you have left remaining, is always the opposite of the first sign. Yeah, so on the sum of cubes, it's going to be minus. What's it going to be on the difference of cubes? Plus, exactly. And there are your two formulas. That is it. So let's see how we're actually, oh, by the way, another note you might want to make is right here. This trinomial, these trinomials in the back, they cannot be factored anymore. All right, so let's take a look at how we would actually solve a problem like this. In this example right here, factor x cubed plus 8. So the first thing that you want, the first thing that you want to see is that make sure both of the terms are perfect cubes, because this only works if both terms are perfect cubes. So on x cubed plus 8, is x cubed a perfect cube? Yes, it is. Is 8 a perfect cube? Is not? It is. 8 is also a perfect cube. So this is going to be one of these, sum of cubes or difference of cubes. All right, so there's two steps here. First, step 1 is we're going to find the cube root of both terms. We're going to find the cube root of both terms And those two terms are going to be, those two values are going to be our a and our b. You see in our formula we had a and b, right? So our a and b is going to be the cube roots of these two terms. Let's see. So let's find the cube root of x cubed. What is the cube root of x cubed? X. It's just x. And so that x is going to be our a value. Okay? Next, let's find the cube root of 8. It is 2, that's right. And that's going to be our b value. All right, so now we're just going to write the formula out. So what is the formula? Do you know which formula we should be using for this problem? The first one, the sum of cubes, because there's an addition sign. So what is the formula using the a's and the b's?
A plus B.
A plus b.
A squared minus AB plus B squared.
That is correct. So you're going to have to memorize this. So yes, make sure you... It's pretty simple. As once you memorize the terms and you get the little trick to remember the signs, then you'll be good. All right, and then now we see this. All we have to do is replace the a's with the x that we found and replace the b's with the 2, and that'll be our answer. So what is going to be my first set of parentheses? X plus 2, very good. And then x squared, right? Minus 2x, right? Which is 4, that's right. And there it is. That's the factored form right there. X plus 2 times x squared minus 2x plus 4. And that's the answer. So let's turn it over to the back. We're going to do 4 different examples to show you different situations, different types of problems you might come across. So first, let's do another basic one. We're going to do x cubed minus 64. This was the answer, right? All you're doing is factoring it out, and that's how you factor out a... Possibly. X cubed minus 64. First thing, remember, you want to make sure that both of the terms are actually perfect cubes. Are those terms perfect cubes? Yes, they are. Okay, so let's get our a and our b value. So let's take the cube root of x cubed. What is the cube root of x cubed? It's x, and that's going to be our a value. All right, and now we're going to take the cube root of 64, which is 4, and that's going to be our b. All right, so let's write the formula out. In the future, you don't have to write the formula out, but right now in the notes, just to get some repetition and help you remember, let's try to write the formula out. What is the formula that we're going to be using this time? The difference of cubes, right? And what is that formula? A minus b times,
A squared
right?
plus AB minus B squared.
What's the last one? The last one's always plus, right? There we go. And so now all we have to do is replace our a's with the x that we found and replace the b's with the 4 that we found. So what is my final answer going to be? X minus 4 times x squared plus 4x plus 16. That's right. Very good. Boom. All right. Let's jump up a level. Let's go to the next one. We're going to do 27 a cubed plus 64b cubed. So once again, first thing you want to do is make sure each term is a perfect cube. Are those perfect cubes? Yes, they are. Because you know the variable part's a cube because it actually has the cube on it, right? And then 27 is a perfect cube. 64 is also a perfect cube. So we're going to take the cube root of each term, right? So the same thing as always. We're going to find the cube root of 27a cubed. We're going to take the cube root of the whole term. So what is the cube root of 27a cubed? Close. 3a. It's a, but yeah, that's right. 3a. Next, let's find the cube root, and that's going to be our, well, in our, it looks really weird because they used a as the variable, right? But just know that, that we're putting this in place of where the a is. Okay, and then we're going to find the cube root of our other term, which would be what? That's right. And what would the cube root of 64b cubed be? 4b, which is going to be our b value. Yeah, bad idea to choose a's and b's here. But anyways, what's our formula going to be?
A minus B.
A what? A plus b. Remember that first sign is the same as the original. And then a squared minus ab plus b squared. Very good. All right, so now we're going to replace each of these variables with what we found up here, the 3a and the 4b. So what's my equation going to be? 3a plus 4b, right? 3a squared? It's a squared, right? 9a squared, that's right. Because look, 3a squared is the same thing as 3a times 3a, which is 9a squared. So your first term in the second parentheses is 9a squared. What's next? Minus 30. Why 36? Why 9 times 4? You're multiplying a and b, right?
Yeah.
What is a?
Oh, so it's just going to be minus 12.
Yeah, it's just going to be 12 because it's just a, which is 3a.
3 times 4.
Yeah, 3 times 4, so 12. I was about to say. Okay, so 12. What are the variables on here? A, B. And then? 16. B squared. And there's the answer. Nice. Nice. Boom, there it is. All right, on to the next one. We got 2 more. This example is going to be 54x cubed minus 16. What is the first thing that you look for on these kind of problems? Checked for perfect cubes, right? We're looking for perfect cubes. Are these perfect cubes? No, they're not. But remember, this is just factoring, right? So all the normal rules that apply to factoring apply here too. So what do you always do first when you're factoring? That's right, you check for the greatest common factor. And what's the greatest common factor between these two terms? 2. I factor out of 2, what's left? Not quite. 27 x cubed minus 8. And so look at that. Once you've factored out your GCF of 2, now both terms are perfect cubes. Yay. All right, so I'm going to go ahead and write the formula first this time so we don't get confused. Our answer should look something like this. 2 times whatever the formula was. So what's the formula going to be in this case? A minus B. Right, a squared plus ab. That is correct. Okay, so now we're going to find a and b so we can write our answer. So we're going to take the cube root of what? What are we going to take the cube root of this time? 27 x cubed, which is 3x. That's right. That's going to be our a value. Then we're also going to take the cube root of, which is, and that's going to be our b. So a is 3x and b is 2. So let's replace the numbers, the values in there, and get our answer. What's my final answer going to be? 2. 3x minus 2. Okay, and then 9x squared, right? Plus 6x plus 4, that's right. And that is the answer. 2 times 3x minus 2 times 9x squared plus 6x plus 4.
You're still trying. What is like the difference of the cube? You're basically adding like the whole thing. And it's like uncertain differences.
Yeah, pretty much. Last example here. It's going to be 3x to the 4th minus 24x. 3x to the 4th minus 24x. What should I do here? Take out the greatest common factor. What is the greatest common factor here? 3x. That's right. So if I factor out a 3x, what's going to be left? Minus 8. And look at that. Once you factor out the GCF, it is now a perfect cube. Both those terms are perfect cubes. Yippee. So my answer should be in the form of 3x times our formula. So what is my formula for this one going to be? The difference of cubes, which is? A minus B. Right. Okay, so can you tell me this time how I'm going to find my A and B? Right, find the cube root of x cubed, right, which is, and that is, okay, and then cube root of 8, which is 2. And that's going to be our b. Yeah, don't worry about the sign, okay? The sign only tells you what your signs are going to be in your formula. Yeah. Yeah. But you're not worrying about that, though. All right, so we found our a and our b, so let's write our final answer. Whoa. What's my final answer going to be? 3x x minus 2 times x squared plus 2x plus 4. That's right. And so with that, that's the last example. That's it, and that's all for today. So until the next time, we will see you then. Peace!